In this video, you will learn about proportions. Now, what is a proportion? A proportion is simply two fractions that are equal to each other. Or in other words, it's an equation stating that two ratios are equal. For example, 4 over 8 equals 1 over 2. You have two fractions that are equal to each other, so that expression would be a proportion. Now we can write this with fractions, or we can write this with colons. So we could write this as 4 colon 8 equals 1 colon 2. Now notice the 4 and the 2 are on the outside of this expression. The term we give to the 4 and the 2, these numbers on the outside, are called the extremes. So extremes mean like outliers, like things that are outside of the normal, right? With numbers, the extremes are outside of the other numbers. And then the 8 and the 1, the numbers on the inside, are called the means. So the extremes are the outside, the means are the two inside numbers. All right, and in general notation, we have A over B equals C over D. A and D in this fraction are the extremes, B and C are the means. Now there is a relationship with the extremes and the means. And the relationship is that the product of the extremes will equal the product of the means. Meaning if I multiply A times D together, that will equal B times C. And this process of multiplying across is called cross multiplying, because we're multiplying across A times B, and then multiplying across C times B. So that is called cross multiplying. And we can verify that that is true if we look at this first example with real numbers. If we multiply across 4 times 2, that is the same thing as multiplying across this way, 8 times 1. So it's a true statement where if I multiply across like this, we have two equal values. So that is the idea of cross multiplying. And I can use this for many things, and the main thing is going to be for solving different equations. So for example, say we had this proportion, x over 3 equals 2 over 5. And the objective is to figure out what must x equal. So to solve for x, what I can do is I can cross multiply. I can take 3 times 2, and that will equal 5 times x. So here we have another equation that would also be true. So 3 times 2 is 6, and then 5 times x would be 5x. And then I can solve very quickly by dividing both sides by 5. When I divide, now I have 6/5 on the left, and then I have x on the right. So x must equal 6 over 5. Let's look at another example. Here we have negative numbers, and here the x is in the bottom instead of the top. To solve for x, this is the same exact process. We can multiply across. So we can take 20 times negative 5. That will equal 3 times 8x. So 20 times a negative 5 would be negative 100. And then 3 times 8 gives me 24x. And then from here I can solve for x by dividing both sides by 24. When I divide on the right side, the 24's cancel. So I have x on the right side and negative 100 over 24 on the left. So x equals negative 100 over 24. I can then reduce by dividing the top and the bottom by 4, which would give me 25 over 6. So my answer for x would equal negative 25 over 6. And if I wanted to, I could write this as a mixed number. This would be negative 4 and 1/6. Here is another example. We have 4 divided by x equals 11. So this one may not be as obvious to you because 11 looks a little different. This is not written as a fraction. But I could write this as a fraction. This is the same thing as 11 over 1. So I have 4 over x equals 11 over 1. And now I can solve, once again, by cross multiplying. I can take 4 times 1, and that's equal to 11 times x. So 4 times 1 equals 11 times x. That is 4 on the left, 11x on the right, and then divide both sides by 11 to get rid of the 11. When I divide, I have x on the right, and then 4 over 11 on the left. So my solution is x equals 4 over 11. Here is another example where now we have something with the x on the top. So it's going to be x minus 2 in this case. So when I cross multiply, be careful because I take 10 times this entire quantity. So think of that as being in parentheses. I have 10 times x minus 2 equals 5 times 3. So I have a new equation and I can solve this. To solve, I distribute the 10. So I have 10 times x and then minus 10 times 2, which would give me 20. And that's equal to 3 times 5, which is 15. So 10x minus 20 equals 15. From here I can solve by doing reverse order of operations. I can get rid of this minus 20 by adding 20. So that will cancel. I have 10x on the left and 35 on the right. I can then divide both sides by 10. That gives me x on the left and then 35 over 10 on the right. And 35 over 10 you can reduce, divide the top and the bottom by 5, and that gives me 7 over 2. And if I write this as a mixed number, this would be 3 and 1/2, or 3.5. Here is another example where now we have x on both the top and the bottom along with other things with the x. So to solve this, once again, I need to cross multiply. So I can take 3 times this entire quantity equals 2 times this entire quantity. So my setup would look like this. Now don't forget the parentheses, all right, because we're multiplying by the entire thing on the top, the entire thing on the bottom. So from here I can solve, and I do that by beginning with distributing. I take 3 times 2x and 3 times 1. That's going to give me 6x and 3. On the right side, I distribute 2. 2 times 4x is 8x. And then 2 times negative 1 is negative 2. So I have 6x plus 3 equals 8x minus 2. Now I need to get x by itself, so I can bring the 6x to the right with the 8x, and I do that by subtracting that over. Because 6x minus 6x will cancel. I have 3 on the left. On the right, I have 8x minus 6x, which is 2x, and then minus 2. And then I need to get rid of this minus 2 and this 2 that's being multiplied. So I do reverse order of operations. So I begin with subtraction, and I get rid of it by adding to both sides. When I add, that will cancel on the right. I have 2x over here equaling 5 on the left. And then I can get rid of the 2 by dividing. So divide both sides by 2. X's will cancel, or 2's will cancel. I have x equaling 5 over 2. And that is equal to 2 and 1/2. So my final answer is x equals 2 and 1/2. So now that we know how to use cross multiplication, I'm going to show you 2 examples where we can actually apply this to real life. So let's say we are making pancakes. All right, so we have 4 cups of pancake mix that can make 10 pancakes. How many pancakes can be made with 6 cups of pancake mix? So what I want to do is create a ratio. So the ratio is comparing the cups of mix to the number of pancakes. So that ratio is 4 to 10, where on the top I have the cups, so the cups of mix, and on the bottom I have the number of pancakes. Alright, so that is my ratio, comparing cups to pancakes. Now that ratio is going to be the same with any number of pancakes that I'm creating. Alright, so this ratio will be equal no matter how many I make. So our second fraction over here, we are going to use the other information that is given to us. So we're asked how many pancakes can be made. So your unknown is the number of pancakes. Pancakes is in the bottom. So down here, for this new fraction, this is your unknown value. For the numerator, we can put the number of cups, which is 6. So we have 6 cups divided by some number of pancakes. So this ratio, these two ratios will be equal to each other, and we need to use cross multiplication to figure out what x will be equal to. So over here, I have the same expression, and I'm going to begin solving by cross multiplying. So I take 4 times x, and that is equal to 6 times 10. So 4 times x is 4x, and then 6 times 10 would be 60. So 4 times x equals 60. I can solve by dividing both sides by 4. When I divide on the left side, I have x remaining, and on the right side, I have 15. So my solution is 15. And what I've just found is that with 6 cups of pancake mix, I can create 15 pancakes. Number 7, we have one more example. Here we are told that in Chandler's Jeep, 10 gallons of gas took him 230 miles. And the question is, how many miles can he expect to drive on 14 gallons? So what I can do is create my ratio with the given the beginning information. So we have 10 gallons. So this is gallons. That took him 230 miles. So that's in miles. All right, so from here, we can use this ratio. We know this ratio will be equal or the same no matter the number of miles or gallons. All right, so for scenario 2, we are asked to determine how many miles can he drive on 14 gallons. So gallons were on the top over here. I need to put gallons on the top over here for scenario 2. So that's going to be 14 on the top. And the question is asking how many miles can he drive. So the number of miles is in the bottom, and that's your unknown. So that will be our x value. So my proportion is 10 over 230 equals 14 over x. So before I cross multiply, I can make this a little bit simpler for myself by dividing the top and the bottom by 10 on this equation, or this ratio. I can write that as 1 over 23 equals 14 over x. So I've made some smaller numbers for myself. So from here I can cross multiply. 1 times x equals 14 times 23. So 1x is the same thing as just regular x. And then 14 times 23 would be 322. So my answer is 322, meaning that on 14 gallons, Chandler can expect to drive about 322 miles. And that concludes our lesson for today. We will see you next time.